Today we will continue the chapter our differentiation. In that the next topic is higher order derivatives. Now what is meant by higher order derivatives? Higher means more, second, third, fourth, fifth, and so on. Now if f of x is a differentiable function of x on an open interval I, then its derivative f dash of x is also a function on I. So f dash of x may have the derivative of its own, and we denote it as f dash of x. Its derivative is f double dash of x. This new function f double dash of x is called the second order derivative of f of x. Now, by Leibniz notation, we can write this as y is equal to, if y is equal to f of x is the given function, then y double dash is the second derivative of f of x. F double dash is the second derivative of f of x. Or we can write it as d by dx of dy by dx. So, or we can write d2y by dx square. So, these are all the notations of the derivative. F dash is the first derivative. F double dash is the second derivative. Dy by dx is the first derivative. D2y by dx square, d2y by dx square is also a notation. It is called second derivative. By method of first principle, derivative is in the first principle. F dash of x is equal to limit f of x plus h minus f of x upon h as h tends to 0. This is the definition of the derivative. This is nothing but dy by dx. And what is the derivative of second derivative? F double dash of x is f dash of x plus h minus f dash of x upon h as h tends to 0. This is called d2y by dx square. Now further, now this is our second derivative. Now if f double dash of x is a differentiable function of x, so whatever derivative we have obtained, if it's possible to find its again derivative, then that means it is differentiable. Then such derivative is denoted by d by dx of f double dash of x. That means f triple dash of x. The new function f triple dash of x is called the third derivative of x, that is third order derivative of f of x. It is denoted by y triple dash is equal to y f triple dash of x or d by dx of d2y by dx square. That means d cube y by dx cube. Similarly, the fourth order derivative is f raised to 4 of x is d4 by d4y by dx raised to 4. So in general, if we generalize this concept, so nth order derivative is denoted by f raised to n of x or y raised to n, or simply d raised to ny by dx raised to n. This is called the nth derivative. Or sometimes it is also denoted by the derivatives are denoted by y1, y2, y3, y4, yn. This means the order of the derivative. Y3 means third order derivative. Y2 means second order derivative. Yn means nth order derivative. So this is the higher order derivative. Higher order, whatever derivatives we have just studied till the date is the first order derivative. Now we are thinking of the second order derivatives, the third order derivatives, the fourth order derivatives, and so on. And after all, then we will generalize the concept for nth order derivatives. Now, for example, let us consider an example. X cube minus x is our given function. So if we differentiate this function with respect to x, we get the derivative, first order derivative, as f dash of x is 3x square minus 1. Now if we again differentiate this function, then what we will get? Derivative of 3x square is 6x, derivative of 1 is 0, so we get the second order derivative 6x. Now if we again differentiate this, then we get the derivative as 6, so third order derivative is a constant. Okay, so again if we differentiate this function, then we will get the fourth order derivative and it is 0, and hence all the derivatives which are from fourth order, they are all 0. So from the above example, we deduce one important result, that if f of x is a polynomial of degree n, here is a polynomial of degree 3. So here, if you consider any polynomial of degree n, then its nth order derivative is constant. Here it is a polynomial of degree 3, so its third order derivative is constant, and all the derivatives, onward derivatives are 0, आणि त्याच्या पुढचे सगळे derivatives काय होतील मग 0 होऊन जातील. Now let us learn some of the solved examples on this topic, how higher order derivatives. Let us find how to find the derivative, higher order derivatives. Find the second order derivative of the following. You have to find second order derivative, means you have to find d2y by dx square. Let y is equal to the given function. Now differentiate this with respect to x. Dy by dx is equal to dy by dx of x cube plus dy by dx of 7x square plus dy by dx of minus 2x, dy by dx of 9. 9 is a constant, its derivative is 0. Derivative of minus 2x is minus 2. Derivative of 7x square is 14x, and derivative of x cube is 3x square. Because we are using the formula, d by dx of x raised to n is n times x raised to n minus 1. This is first order derivative. Now again differentiate with respect to x, d by dx of dy by dx. So we are finding the derivative of the derivative. So d by dx of dy by dx is equal to d by dx of 3x square plus 14x minus 2. So the derivative of the 3x square is 3 into 2 into x is 6x. Derivative of 14x is 14. Derivative of minus 2 is 0. So d2y by dx square is 6x plus 14. This is our second order derivative. Now for the function x square e raised to x, let y is equal to x square e raised to x. Differentiate with respect to x. Then we obtain dy by dx is equal to d by dx of x square e raised to x. Now dy by dx is equal to x square into d by dx of e raised to x plus e raised to x into d by dx of x square. This is the product rule. As there is a product of two functions, we have to use the product rule. First function as it is into d by dx of the second function, then second function as it is, then derivative of the first function. Now derivative of e raised to x is e raised to x, and that of the derivative of x square is 2x. So this is the derivative, but we can take x e raised to x common from this, or we simply x e raised to x is common. So the derivative dy by dx is e raised to x, x square plus 2x. Now again differentiate with respect to x because we want to find second order derivative. So derivative of the derivative, dy by dx of dy by dx. So it is nothing but d2y by dx square. And here again we got the product of the two functions. So first function as it is, derivative of the second function, plus second function as it is, derivative of the first function. So derivative of x square plus 2x is 2x plus 2, and derivative of e raised to x is e raised to x. So what we got, e raised to x in bracket x square plus 4x plus 2 is the derivative of the given function. The next example is e raised to 2x sine 3x. Let y is equal to e raised to 2x sine 3x. We have to find this second order derivative. So differentiate with respect to x, dy by dx of e raised to 2x sine 3x. Here there is a product of two functions, so keep first function as it is into derivative of the second function, plus keep second function as it is into derivative of the first function. So we get the derivative as e raised to 2x in bracket 3 cos 3x plus 2 sine 3x. Now again differentiate with respect to x. So d by dx of this function, there is a product of function, so e raised to 2x as it is, d by dx of this 3 cos 3x plus 2 sine 3x, plus we will keep this bracket 3 cos 3x plus 2 sine 3x as it is into derivative of the first function. So the derivative of e raised to 2x as it is, derivative of 3 cos 3x plus 2 sine 3x is minus sine 3x into 3, because we are using cos f of x. Cos f of x, its derivative is minus sine f of x into f dash of x. Similarly, sine f of x is cos f of x into f dash of x. F dash of x means derivative of 3x. Its derivative is 3. Similarly, derivative of e raised to 2x is e raised to f of x. Its derivative is e raised to f of x into f dash of x, means derivative of 2x is 2. So taking e raised to 2x common from all these brackets, then and simplify it, you get minus 9 sine 3x plus 6 cos 3x plus 6 cos 3x plus 4 sin 3x. Taking addition and subtraction, we will get d2y by dx square is equal to e raised to 2x in bracket 12 cos 3x minus 5 sin 3x. This is the second order derivative. Now, next example, x square log x. Now differentiate with respect to x using the product rule. First function as it is derivative of the second function plus second function as it is derivative of the first one. So derivative of log x is 1 upon x and derivative of x square is 2x. So here 1x is cancelled and we get dy by dx as x in bracket 1 plus 2 log x. Now again differentiating with respect to x, so that we get the second order derivative using the product rule. First function as it is derivative of the second plus second function as it is derivative of the first one. So derivative of 1 is 0 and derivative of 2 log x is 2 upon x. Same the derivative of x is 1. So here x will cancel. We get 2 plus 1 plus 2 log x. That means 2 plus 1 is 3. 3 plus 2 log x is the second order derivative of the function x square log x. The next example is sine of log x. Let y is equal to sine of log x, then differentiate with respect to x. We have to use the sine of f of x. Sine of f of x derivative is cos of f of x into f dash of x divided x of log x. So log x derivative is 1 upon x. So we get dy by dx as cos of log x upon x. Now differentiate with respect to x. So d by dx of dy by dx, dy dx of cos of log x upon x. Now here we have to use a quotient rule. How to use the quotient rule? 1 upon the x square, x as it is. So square of the denominator, okay? Square of the denominator, then denominator as it is in the numerator into d by dx of the numerator minus numerator as it is into d by dx of the denominator. By using that formula, find the derivatives. What you get? Minus x log of x upon x in minus log of cos of log x upon x square. So after simplifying, taking minus sign common, we get sine of log x minus minus sine log x plus cos log x upon x square. Now go to next example. We have to find d2y by dx square if x is equal to cot inverse of square root of 1 minus t square upon t and y is equal to cosec inverse of 1 plus t square upon 2t. Now, whatever examples we saw, there are single examples. So only y is given in terms of x and we have to find the derivative, second derivative. Now here x is expressed in terms of t, y is expressed in terms of t. So x and y are the parametric functions with the parameter t. And you have to use this parametric differentiation to find the second order derivative. Now, if it's possible, we can simplify these two and we will get the functional relationship between y and x if it is possible. But sometimes it is not possible. So as here is also, it is not possible to get the relation, common relation, functional relationship between x and y. So we have to take x derivative of x with respect to t and derivative of y with respect to t. Then we will use the parametric differentiation. Dy by dx is equal to dy by dt upon dx by dt. Okay. So let cot x is equal to cot inverse of root 1 minus t square upon t. So what is x? X is equal to 1 plus cosec inverse. No, so sorry. Y is equal to cosec inverse of 1 plus t square upon 2t. So put t is equal to sine t. So put t is equal to sine theta, means theta is equal to sine inverse of t. So what you get? X is equal to cot inverse square root of 1 minus sine square theta upon sine theta is equal to cot inverse 1 minus sine square theta is cos square theta, but root cos square theta is only simply cos theta. Cos theta upon sine theta is cot theta. So cot inverse of cot theta is theta. Okay, so x is equal to sine inverse of t. Now differentiating with respect to t, dx by dt is equal to d by dt of sine inverse of t. It is 1 upon root 1 minus t square. This is our equation number 1. Now take our second function y. Y is equal to cosec inverse of 1 plus t square upon 2t. So cosec inverse of x can be written as sine inverse of 1 upon x. So it look like 2 tan theta upon 1 plus tan square theta. So you have to put t is equal to tan theta. So theta is equal to tan inverse of t. So sine inverse of 2 tan theta upon 1 plus tan square theta. So sine of 2 theta. Sine cancel, we get 2 theta. So y is equal to 2 times tan inverse of t. Now we will differentiate this with respect to t. So tan inverse of t, its derivative is 1 upon 1 plus t square, and this 2 is there. So 2 upon 1 plus t square. This is our equation number 2. So using the parametric differentiation, dy by dx is equal to dy by dt upon dx by dt. Put the values of dy by dt and dx by dt. We get dy by dx is 2 root 1 minus t square upon 1 plus t square. Now differentiate these with respect to x. So d by dx of dy by dx is equal to d by dx of this. Now but here there is no x, so this function is not expressed as in variable of x, but we are differentiating with respect to x, so it is not possible to differentiate with respect to x. So firstly we have to differentiate this with respect to t, and then that t with respect to x. This is called chain rule because it is a composite function. X and y are functions of t, and we are differentiating this t directly with respect to x. It is not possible, so we have to firstly we have to differentiate this function with respect to t, and then that t with respect to x. Now d by dt of root 1 minus t square upon 1 plus t square. Here we have to use the quotient rule. Square of the denominator as it is, derivative of the numerator, minus numerator as it is, derivative of the denominator, into this dt by dx can be written as using the derivatives of the inverse function. Dt by dx is 1 upon dx by dt, and we have dx by dt. Dx by dt is 1 upon root 1 minus t square. So we will put that value and we will simplify this derivative. Derivative of root 1 minus t square is 1 upon root 2 root 1 minus t square into d by dt of 1 minus t square is minus 2t. So this 2 will cancel each other. Okay, and we'll get 1 plus t square into minus t upon root 1 minus t square minus root 1 minus t square into 2t divided by 1 plus t square bracket square into root 1 minus t square. Now we have to simplify this, taking the LCM over here, cross multiplication. This, if you multiply this root 1 minus t square to this root 1 minus t square, we get 1 minus t square, and denominator this denominator will cancel to this 1 root 1 minus t square. So minus t into 1 plus t square. So minus 2t into 1 minus t square. So after simplifying, you get t cube minus 3t upon 1 plus t square bracket square 2 times. This is the derivative, second order derivative of the given function. Now d2y by dx square, x is equal to a cos cube theta and y is equal to b sin cube theta at theta is equal to pi by 4. Now again further, we want a second order derivative, but at particular point. Uh, we have just find out the value of the parametric derivative at the particular point. Given x is equal to a cos cube theta, so differentiating with respect to theta, a is a constant, so we can take outside. Derivative of cos cube theta is 3 cos square theta into minus sin theta is minus 3a cos square theta sin theta. Similarly, y take it differentiating with respect to theta. Okay, on the same line, you will get 3b sin square theta into cos theta. Now, using the parametric differentiation, we get the derivative as minus b by a tan theta. We have to differentiate this with respect to x. So d by dx of dy by dx minus b upon is constant and d by dx of tan theta. But here there is no theta. there is no x, so you have to differentiate firstly with respect to theta and then that theta with respect to x. Then we will use the inverse differentiation formula. We can write this d theta by dx as 1 upon dx by d theta, and its derivative, we know that its derivative is minus 3a cos square theta sin theta. Now what we will do, this minus and minus will cancel to each other. This cos square theta will go in the numerator, it becomes sec square theta, and original sec square theta, their product is sec raised to 4 theta, and this sin theta we will keep as it is, or you can take it also in the numerator by it will be cosec theta. Now we want the second order derivative at theta is equal to pi by 4, so you have to put the theta is equal to pi by 4 in this derivative. Now sec raised to 4 pi by 4 upon sin pi by 4. Now sin pi by 4 is 1 by root 2 and sec pi by 4 is root 2. So root 2 raised to 4 is 4, and 1 upon divided by 1 upon root 2. So this root 2 will go to the numerator and you will get 4 root 2b upon 3a square is the derivative of the given function. Now ax square plus 2hxy plus by square is equal to 0. Then you have to show that d2y by dx square is equal to 0. What is this? Already we have learned such type of expressions. What is this? It is the second degree homogeneous equation in x and y, and what it represents, it represents a pair of straight line. Okay, so take the equation. Now firstly we will simplify it. This 2hxy, I will write hxy plus hxy, then take x common from these first two and y common from this second, so we'll get ax plus hy and hx plus by. Now this y hx plus by is equal to this term will go to that side and it becomes minus. So what you get, y by x is minus ax plus hy upon hx plus by. Why we have find out the value of y by x? Because we need it in the derivative. So differentiating with respect to x, the given function, equation number 1, we have to differentiate. Now a is a constant, derivative of x square is a 2x, and derivative of 2h is a constant, d by dx of xy. Now to find the derivative of xy, we have to use the product rule. First function as it is derivative of the second function plus second function as it is derivative of the first one plus b times d by dx of y square. So its derivative is 2y dy by dx. So after finding the derivative, take dy by dx common from these two terms and find out the value of dy by dx. So what is dy by dx? Dy by dx is minus ax plus hy upon hx plus by. But what is this? Already we have find out the value of this ax plus hy upon hx plus by, and it comes out to be y upon x. So the derivative dy by dx is y by x. We want d2y by dx. So differentiate this function with respect to x. We get a denominator square, denominator as it is, derivative of the numerator minus numerator as it is, derivative of the denominator. So x into y by x minus y upon x square. So d2y by dx square is y minus y upon x square. So 0 upon x square is 0. So we get d2y by dx square is 0. Y is equal to cos of m cos inverse of x. Then you have to show that 1 minus x square d2y by dx square minus x dy by dx plus m square y is equal to 0. Now here there are many methods to solve this, to show this equation. We can find a dy by dx. This is y is already given, so it is our equation number 1. Now we can find dy by dx from this equation. This is our equation number 2. Then we can find its second order derivative. This is our equation number 3. Then finally we will what we will do, we will take this left, we will consider this left hand side only, and we will put all our derivatives in this left hand side. What answer we must got? We must got 0. आपल्याला शेवटी 0 मिळायला पाहिजे. So left hand side is equal to right hand side, so that this is the equation that we want to show. Now here what we are going to do, we are just simplifying, arranging, finding the derivatives, and at the same time we will arrange those terms so that we can reach to this uh, equation. Notice y is given, y is cos of m cos inverse x. So we can write it as cos inverse of y is equal to m cos inverse of x. Now this is our equation number 1. Then we will differentiate this equation. What we get? D by dx of cos inverse of y is equal to, m is a constant, so m times d by dx of cos inverse of x. Now cos inverse of x, its derivative is minus 1 upon root 1 minus x square. Similarly, cos inverse of y, its derivative is minus 1 upon root 1 minus y square into dy by dx, because here it is a variable y and we are differentiating with respect to x. So firstly we have to differentiate with respect to y, and then we have to differentiate y with respect to x. So what we got, root 1 minus x square dy by dx is equal to m times root 1 minus y square. Now take the square on both the sides. What you will get, 1 minus x square into dy by dx bracket square is equal to m square 1 minus y square. Now differentiate this with respect to x. Now here there is a product of two functions. So you have to use the product rule. 1 minus x square as it is, d by dx of dy by dx bracket square plus dy by dx bracket square as it is into d by dx of 1 minus x square in is equal to m square into d by dx of 1 minus y square. Now this, how to find dy by dx bracket square's derivative? It is f of x square. What is the derivative of f of x square? Is 2 times f of x into f dash of x. 2 times f of x into f dash of x, and derivative of 1 minus 2x square, derivative of 1 is 0 and x square is 2x, so you get minus 2x. And here also derivative of 1 is 0, derivative of minus y square with respect to x is minus 2y into dy by dx. Now if you look at this equation, you will find that each term contain 2 dy by dx, 2 dy by dx, 2 dy by dx, 2 dy by dx. So we can thoroughly divide the 2 dy by dx. So what we will get? 1 minus x square d2y by dx square minus x 1 dy by dx will remain here minus m square y. We can take this m square to this side, and whatever answer we got, this is what we want to show. Okay, so this is the way by which we are showing the given result. Now the fifth example, what is x? X is sine t. What is y? E raised to mt. Then you have to show that this equation. Now as x is equal to sine t, so t is equal to sine inverse of x. Y is equal to e raised to mt, so y is equal to e raised to m times sine inverse of x. So differentiating with respect to x, so now it is not a parametric differentiation, okay, because we have obtained a relationship, functional relationship between x and y from these two parametric equations, that y is equal to e raised to m times sine inverse of x. So y is expressed in terms of x, so we directly differentiate with respect to x. E raised to f of x, its derivative is e raised to f of x into f dash of x. So m times d by dx of sine inverse of x, but derivative of sine inverse of x is 1 upon root 1 minus x square. So take this root to that side, we will get root minus x square divided by dx is equal to m1. Now take the square on both sides. Why we are taking the square? Because here 1 minus x square is there. So and here root 1 minus x square is there. So after taking the square, differentiate with respect to x. Here you have to use the product rule. First function as it is derivative of the second plus second function as it is derivative of the first one. So 1 minus x square, derivative of this is 2 dy by dx into d by dx of dy by dx. Then this as it is, derivative of 1 minus x square is minus 2x. Derivative of y square is 2y dy by dx. Now here is also each term contains 2 dy by dx. So we can cancel throughout the term, and we get 1 minus x square d2y by dx square minus x dy by dx is equal to m square y. We take to that side, we get 1 minus x square d2y by dx square minus x dy by dx minus m square y is equal to 0. So this is all about the solved examples based on the higher order derivatives. Okay, we will continue this topic in next lecture. We will study the successive differentiation.